This next example is another very typical two-step equation that you should be used to solving without really thinking about the reverse order of operations. So again, this one is solved in the typical order: add or subtract, and then multiply, divide. In order to undo addition by 4, I'm going to subtract 4 from both sides of my equation. So x divided by 2 plus 4 minus 4 leaves me with x divided by 2. And then negative 6 minus 4 is negative 10, because I'm really comfortable with inverse operations. My final inverse, did I say inverse? I meant integer operations. My final inverse operation is to undo division by 2 by multiplying both sides of my equation by 2. So x divided by 2 times 2 leaves me with x, and then my solution is just negative 10 times 2, which is negative 20. X equals negative 20. Now here is one that is a great example to understand why we really need to think about order of operations. So notice here I'm dividing by 2 and I'm adding 4, so my inverse operations should be minus 4 and times 2. But the same operations are happening here, plus 4 divided by 2, but I'm going to have a different solution, and let's think about why. In this first example, when I trace through what's happening to x, first I'm dividing by 2 and then I'm adding 4. That means my inverse operations need to happen in this order. First, I undo the plus 4 with subtraction of 4, and then I undo dividing by 2 by multiplying by 2. So my reverse order of operations is minus 4 times 2. That will be different for this example. Let's see why. In the original equation, I have x plus 4 in my numerator, so the first thing that's happening to x is I'm adding 4. This is very similar to my previous example because it's like I have an invisible parentheses here. My fraction bar is like having parentheses. So the first thing that I do to x is I add 4, and then I divide that expression by 2. What this means is that when I perform inverse operations in opposite order of operations, is that my first inverse operation is to multiply by 2, and my second inverse operation is to subtract 4. So my inverse operations are the same, minus 4 times 2, but they're performed in a different order because of my order of operations, and therefore my reverse order of operations. This flowchart is not required, but it may help you, at least to do it mentally, to figure out how to solve this equation. So since I have plus 4 divided by 2, my first inverse operation is to undo that division by 2 by multiplying both sides of the equation by 2. So times 2 on both sides. X plus 4 divided by 2 times 2 leaves me with x plus 4 equals negative 6 times 2, which is negative 12. My second inverse operation is to subtract 4 to undo this addition of 4. Subtracting 4 from both sides, x plus 4 minus 4 just leaves me with x, and then negative 12 minus 4 is negative 16, which is my solution to the second equation. Notice really similar equations, but different solutions.